Sure. Okay. Okay, so you have yourself a nice square here, and then to turn this into a 3D shape, what you want to do is just extend out 4 lines, the same angle. So you can take your ruler, you can rotate a little bit, go like the same length, like, you know, like a couple centimeters or something, and just draw a couple diagonal lines. So just boom, they're all the same length, right? Boom, boom, boom. These are all about the same length. And then just connect the lines. All of a sudden, we have ourselves a room. So if you ever want to make a 3D shape, just draw the shape twice and then draw some diagonal lines that connect them. Congratulations, you have a 3D shape. It's going to work for anything.
Sorry, I lost my pencil.
Oh, do you need one?
Oh, I think I got it.
How did I do this? So what I did was I drew a square. Don't draw what I'm doing here, but so I drew a square. You can draw like another square like this if you want, like start down here, just go like, you can do a rectangle too, that's fine too. And then I just connect the two of them. All of a sudden it's 3D, right?
We have to use those measurements to draw it, or we just...
You can, you know, just make yourself like a nice 3D model of a room. Yeah, it can be a rectangle, it can be a square, it can be whatever. We just wanted something to draw because we want to be able to label this. It'll be easier then. So, yes, I can use text now. Can I? Sorry, I'm just gonna be sampling stuff. Okay, cool. Yes, this is gonna work good. I like it. All right, so let's once we have a room, let's put some measurements to it. So it is going to be 12.5 feet long. Why don't we say that's this thing here? So 22.5 feet. And first off, is everyone able to read that? Okay. No one is saying no, and it's okay to say no. Okay, so this distance here is 22.5 feet, 22.5 feet long, right? Then we're going to have 13.5 feet wide. Frankly, it doesn't matter. At the end of the day, you're going to get the same amount of paint, but 13.5 feet wide. And then we're going to say it's 2.5 feet. No, not 8.5 feet tall. Do you notice how all my measurements are on the outside to start, right? Free up that space inside. You're going to need it. Okay, so I'll give you like a couple seconds here. Okay, so I'm not done with my drawing yet because what else is in that drawing? Yeah, there's windows and doors. So let's go through that one by one. Now, does it matter where it goes? No, at the end of the day, you're gonna have to paint. Doesn't matter if it's on this wall or that wall. There's a window there that you need to. So I'm just gonna put it. I'm just gonna put it on the back wall just because that's the easiest thing I can see. So we're gonna say the back wall is gonna have the 10-foot by 6-foot window. So I'm just drawing a 10-foot by 6-foot window there. And I'm going to label those dimensions, right? So 10 feet by 10.5 feet by 6 feet. Is blue an okay color, or do we prefer red? Okay, so next we have two windows that are 3.5 feet by 2.5 feet. I'm just going to throw those bad boys down here. This house doesn't need to make sense. We just need to have the right stuff in it. So I have two windows here. Each one is 3.5 by 2.5 feet. And then we also have two doors that are 2.5 by 8 feet. I'm just going to throw my doors here just on the, oh gosh, just on the side like that. So throwing my two doors on each side. Straight line, slanted line, straight line. Put a little doorknob so we know, sure. And each door is 2.5 feet wide and 8 feet tall. So it makes sense you're going to have a taller door.
By 8 feet.
By 8. Yes, by 8 feet. So first off, this is a messy picture, right? With all the other stuff, we made like direct things on the picture. With this one, we don't. It just helps to kind of see it sometimes. So when it asks like what surface area must he paint, again, don't tell me in math, tell me in English. How am I going to figure that out? What do I have to paint here? Just tell me, like what sides do I have to paint?
Everything on the inside.
Everything on the inside?
Doors, windows.
Did you say except or?
No, he said ceiling.
Oh yeah. So we know that we're only painting the walls and the ceiling. So we're painting the top and then all four sides, but not the floor, right? So we're not painting the floor. And then we also know, so there's a window and like doors and stuff. We don't paint those, do we? When you paint like an inside of a house, you don't paint over the window. You want to see through them. So what we know. So how am I going to figure out the surface area of the paint? Again, say it in English and not in math. I'm going to take so SA surface area. So the SA, I'm just going to put of my 5 sides. Wait, no, what am I doing? I can type this now. Black. So I can take my surface area of 5 sides minus the windows and doors. Oh, so we're only doing the 5 sides. Yeah, but you're right. If I said 6, that's another way to do it though, Stephen. You could have found it all 6 and then took the floor away from it too. That works too. There's multiple ways of doing this. So in English, that makes sense, right? It's when we throw the numbers there that gets to be a little bit of a pain. But we understand what that means now. Oh, no, don't leave. So let's start working that out then. Let's start doing the math with that one. So let's find out the surface area of my 5 sides. So this is where I'm going back to there's a lot of measurements in there. I only care about the 3 on the outside now, right? There's a reason outside stuff, inside stuff. So let's find the surface area of my 5 sides. So let's do the front and the back. So what am I going to say? I'm just going to say F plus B. Does that make sense? Front plus back? So so first off, what shape is it? What shape is this front? Is it a square? It looks like it. But what's our measurements, right? If it's a square, it'll have the same measurements, but it doesn't. It looks like a square. That's just because I'm a crappy artist. Sorry? It's a rectangle, you betcha. So we know this is a rectangle. And what's my area to find a rectangle? Oh, gee, I don't know. Page 2 does, though. It's length times width, right? Or just L times W. Because again, mathematicians are lazy. We're cool with this. So it's length times width. So if I substitute those in, what two numbers am I multiplying together here now? What's my length of the front wall?
13.5.
Yep, 13.5 feet. And I'm timesing that by what? Is it 22.5? Because if we do that, that's just the floor, right? It's the 8.5, right? It's this wall here. So, and if you're ever unsure, this is why those rulers are kind of nice. If you're ever unsure which measurements for what, take your ruler. I know I need to do this line, right? This is the line I'm trying to figure out. Go through until you find something that has that measurement. It'll be the exact same angle and it should be about the same length as well. So if you're ever unsure, you can't eyeball it, you can just explore with your ruler. It should give you the answer there. Okay, so it's 13.5 feet times 8.5 feet. Now, we have been given the technology of calculators. So I just literally times those out, right? Oops. 13.5 times 8.5. 11. So do you guys get this on your calculator? So if you want to, oh, how do I do that on this one? How do I turn you into a decimal? Nope. Bear with me 1 second while I figure this out on this calculator.
SD.
Is it SD? Okay, let's take a look then. Where's my SD? Aha, wait, there we go, change. You have this change button here. This turns it from a mixed fraction to an improper fraction to a decimal. We're just gonna keep it in decimals here. What does it give me? Does that make sense where that button is? Right here. Superb. So it's 114.75 what? So it's 114.75. I times these out. What does that give me? Gives me 114.75. What's at the end? Feet squared, right? Okay, cool. So I now have the area of the front and the back. So now I'm just going to do the left side and right side. And again, because we're lazy, but we also want to keep organized, we're just going to go side plus side, right? That makes sense? One side and one side. So what shape are sides here? That's this little thing here. What kind of shape is that? Don't do what it looks like. Look at the measurements. Yeah, it's still a rectangle. You could almost argue it's like a parallelogram with how it looks, but we know it's a room, right? This is okay, this is not a good example. Oh crap, wow. Okay, this room is not a good example of a rectangle. But it's a rectangle, right? And what's my formula for rectangle? Yeah, that could be a good one. Length times width, right? Rectangle's length times width. For ever unsure, that's on page 2. So, okay, so what measurements am I multiplying now?
22.5.
Yeah, 22.5 feet times 8.5 feet. I multiply those together. Okay, can I type? Nope. Oh gosh. Okay, screw it. 22.5 times 8.5. I won't do this. I just wanted to show it all the time. Just want to show you. Press the change button. 191.25 feet squared. Okay. So now we're on like a formatted thing. You can either go right here, you can keep going below. Frankly, whatever works for you. You keep it organized, right? Doesn't matter. I'm just going to keep going down low. You can do whatever you want there. But what's my last thing I need to do?
The ceiling.
The ceiling. And how come I'm not doing the floor? Doesn't need to be done, right? Because you know, it's a surface area of 5 sides minus the windows and doors. So ceiling, roof. That is a rectangle. So I can find that by going length. So the area of this is equal to, I should have been doing this the whole time, putting the A in there, length times width. So the area of this, what two numbers? Austin? What two numbers do I multiply to get the roof?
The 13.5 and 22.5.
You betcha. 13.5 feet times 22.5 feet gives me, I'm just gonna use my own calculator now, 22.5 times 13.5. 303. So area equals 303.75 feet squared. 303. Does it make sense where I got all these figures from, right? Cool. So I have an equation, right? I have made myself an equation to answer this, which was the surface area of 5 sides minus the windows and doors. I now have half of that, don't I? I have the total surface area of this whole thing as if there was no windows and doors in it. So how can I figure this out? Well, the surface area of 5 sides is just, so SA of 5 sides equals, now does it make sense where I'm getting these numbers from? F, or these letters from? F plus B plus S plus roof? It's the front, the back, the side, and the roof. Again, we're lazy, so we're keeping it short. So I could type this in. I could type in 114.75 plus 114.75, but I don't want to. And then it's also really important to know, this is only the dimensions of one of the front or the back. It's not the front and the back, right? So what I'm going to do here is I'm just going to take, sorry, I realize that's blocking me. Can I do? Okay, I'm just gonna move it out of the way for a second, let you guys get caught up. Okay. So what I'm going to do then is I'm just going to add all these up. So I'm doing the front and the back, right? So it's 114.75. Now remember, this is only the dimensions of one of those fronts and backs, not both. So I need to add that together again, 114.75. Then I need to add both sides together, right? So two of these together, 191.25 plus 191.25. And then I just need to add one of just the roof. That's also the ceiling, but just the roof. So I only add this bottom one once. And when I do that, I combine it all, I end up getting change, 915.75. So 915.75 feet squared, right? Okay, this seems important. So what am I going to do? I'm going to circle or square it or something, right? Make it stand out. I have half of my equation now. What do I need to do now? Don't tell me in math, tell me in English.
Subtract the windows and the doors from this.
Yeah, got to find the windows and doors and take it away from it. So let's find that out. First off, do we like the text better than the scribble?
Yeah, it's a lot better.
Okay, good. Okay, so let's find that out here. So it's going to go down here. The window. So let's say big window, big W, big window, right? Big window is this one here. What shape is it? Rectangle. We've been blessed to have only rectangles. So this one is length times width. Oops. Length times width So what two numbers do I multiply together for the big one?
Me? 10.5.
10.5 times what?
Multiply by 6.
Oh, by 6. Okay. Sorry, bad ears. Wait, what? Where did it? Oh, there. But sorry, 10.5 feet times 6 feet. There we go. And if I multiply those together, I should get 63 feet squared. Sounds right. Looks right. Cool. I have my big window. Now let's do my small window. Now there's two of them, but they're the same size, right? There's two windows that are 3.5 times 2.5. So I'm just going to put small window. I'll just figure out one of them because if I know the area of one of them, I know the area of both of them, right? So I know it's a rectangle. Hannah, what's my formula for a rectangle? Length times width, right? So area equal, oh gosh. So area equals, I'm going to times the length times width of the small windows. Those ones are 3.5 feet by 2.5 feet, right? 3.5 feet times 2.5 feet. And if I times those together, I get 8.25, or say 8.75 feet squared. Cool. So I have the windows now. The final piece of the puzzle is the doors. And again, this small window, there are two of them. So I need to keep that in my head somewhere. Yeah, you can times that by 2. Again, there's a ton of ways of doing this. Once you get to these complex problems, this is why showing our work's important. So next I just have the door. Doors technically. Doors are a rectangle. Anna, what's my formula for rectangles? You betcha. That's to find the area of a rectangle. So length times width. I know the doors are 2.5 times 8.5 feet. 2.5 times, sorry, 2.5 times 8 feet. Yeah. Okay. And so when I times those together, I should end up getting 20 feet squared. Cool. So now I know the size of everything in that. I know every single thing there is to know about that. Now all I need to do is add all that stuff up. Specifically, add all of these windows and doors up, because this is the stuff I'm taking away, right? So I know that, what did I say? The windows and doors? So windows and doors. So there is one big window, two small windows, and two doors, right? Does it make sense where I've gotten these from? Let's write that into a formula instead. Make that a little bit nicer. Okay. What am I doing? Okay. Okay. Oh God, I just ruined it. Windows and door. So what did I say? Big windows, small window, door. Sure, let's do that. Okay. Sorry, not that. Equals. It's a mathematical equation. Okay, so all I do now, again, I could do 63 plus 8.75 plus 8.75 plus 20 plus 20. I'm just going to do it on my calculator, right? So 63 plus 8.75 plus 8.75 plus 20 gives me 120.5. So 125 feet, 120.5 feet squared. That is an important figure. I'm going to square it or circle it or something. Make sure it stands out. That is noteworthy. What's my last step? Subtract what? What from what? Let's be specific now.
You subtract 125 feet from 115.
You betcha. Yeah. So remember, my original equation was the 5 sides minus the windows and doors. The 5 sides are 915. And what was the other figure? Point what? 0.75 feet squared. Subtract 120.5 feet squared. So what's that going to give me? That gives me 795.25 feet squared. Am I done? So I'll give you a second to catch up. Then I'll ask. You should know by now it's a trick question. We're never done. Okay. So again, what does the question ask us? What surface area must he paint? Okay, that actually answers the question. Sometimes we have to go back to the question and make a statement. This is not one of those times. So always make sure you go back and double check, did you actually answer the question? Because for example, if this question here said, he only has enough paint to paint 800 square feet, does he have enough? That changes it. We didn't need to make a statement. Yes, he has enough paint because he only needs to paint this much. In this case though, boom, we're done. We're good. Here it is. So first off, I'm just going to write this figure down, 795.25, because I know this is going to be important. So 795.25 feet squared. So question B here asks about the paint. So we know that that's how much I need to paint, right? That's how much surface area I need to do. I had to do this when I painted my house. I had to calculate how much 1 gallon of paint does and how much that costs and how many coats, all this stuff. So this is how much I have. And this is how much I know 1 gallon covers. So how many gallons would I have to buy? How can I figure this out?
Subtract 255, however many times from surface area.
Yeah, figure out how many of these go into this, right? So you could subtract it. You could do 295 minus 255 and take that answer. You could do that. That's fine. That would be acceptable. I'm just going to do it over here just because this is something we've done before in the past in the class. You can do your method perfectly fine. That works. So something I want to point out as well. You see this SQ dot feet? That means square feet. You see that? That means this little 2 thing. Okay. This is feet squared, square feet. So 255, I add another 255 to this, I will get 510. Add another 255 to that, I'll get 765. Again, you can use your calculator for this. And then if I do another 255 on that, I would get, now I'm going to use my calculator. What is that, 1020? Yeah, 1020. So how many of these fit into this? 3. But how many gallons do I need to buy? How come I need to buy 4? Sorry? Yeah, you won't cover everything. You won't have enough, right? So you need to buy 4 gallons. So how many gallons of paint will I need to buy? You need to buy, oh gosh, what am I doing? I can really just type it. You need to buy 4 gallons of paint, right? And now this would be an acceptable answer as long as you have the math there. You can't just say, you can't just say you need to buy 4. I need to see some reason in there. So you could work this answer on your calculator, but I needed to see some workings. This is workings. Or if you did that 795 minus 255, that's workings. All right. And final question. We've gone so much further from just like a measurements, right? Again, this is super real world math. Like this is exactly what's done with it. So last question here. If paint costs $55.40 per gallon, he wants to profit $225. How much should he charge to paint the room? If you ever go take out a small business loan, they're going to ask you this stuff. What's your profit margins? How much are you going to charge? How much are you going to profit? So how can I figure this out in English, not in math?
Figure out how much 4 gallons costs.
Yeah. So figure out. You don't need to write this down. You don't need to write this down. That's fine. So figure out how much 4 gallons costs. Then what do I do with that info?
See how far off of $225.
Yeah. See how far away 225 point whatever it was XX is from it, right? So I need to figure out how much it's costing me. This is how much I might want to make, and then I'm just gonna combine them, right, to set my price. So let's turn that into math now. So I know. So the paint's gonna cost me, if it's $55.40 per gallon. How many gallons? 4. If I multiply those together, I'm going to end up with a whopping, I literally could just do this in my head. I don't know why I'm using a calculator, but yeah, 221.6, not $0.6, it's dollars, right? 60 cents, not 6 cents, 60. Make sure that zero's there. So this is how much it's going to cost me, right? Cool. So how can I use this again to figure out how much I should charge? He wants to make $225 on top of this. So I know how much it costs to paint the room now. How can I turn that into profit? How can I set a proper price so I make money? Let's make it easier numbers. I will mow your grass, but the cost to run my mower costs me $5, but I want to profit $10. How much do I charge you? I want to profit 10, not get 10 back. I'll charge you 15 bucks then, right? So you added them together, right? That's what you did with easier numbers. So if I want to figure out how much, if I want to profit $225, don't I just take, this is how much it cost me. This is how much I want to make. Together, those form my cost, $446.60. Oops. Ooh. So this is how much I am going to, again, it's my answer. I'm going to circle it. This is how much I charge if I want to profit that much money. And you see this everywhere you go. Any restaurant you have, they figured out how much does it cost me to make this steak, to pay my workers, to run the gas, and then they figure out how much money they're going to get back. So normally the markup, so this is about a 1-to-1 markup, right? For every dollar you put in, you charge the $1 profit. In a restaurant, it's normally about like a 1-to-3 markup. For every dollar you spend on like that meat, you're getting 3 back. So it's a lot. That's why it's so much more expensive to eat at restaurants, right? Because you're paying like 3 or 4 times more for someone to make it for you, for the experience.
What if you go to like buffet?
Then I would say the more you eat, the better value. But with their signs behind buffets, they put like the cheap stuff to make that fills you up earlier at the very start. So you grab that, and then by the time you get to the expensive stuff, your plate's too full, so you don't want to add more, or you're too full, so you don't go grab it. Buffets are an interesting science. Okay, so this is a lot of math. What I'm going to do is I'm going to let you guys keep kind of firing through here. So keep kind of going on to the practice here. I want you to try and get to, don't worry about question 5, scratch it out. We don't need to worry about it. Ignore it. I want you just to go to all the way up until page, oh gosh. 19, I guess. So this is your time to do some practice here. You're not going to get all class for it, maybe. Maybe you will, maybe. No, you won't get all class for it, but you'll get most of the class for it. So do your practice now. Refer to your notes when you need it. I'm going to stop recording this. Or rather, I'm going to pause recording. Zoom recording. So this question here is asking you to show 4 different ways you could divide the figure below to calculate its area. So there's 4 different ways you could do this. Remember, we've talked a lot today and yesterday about there's multiple ways you can solve a question. In this case, I'm going to show you the 4 different ways. So the first thing I could do is I could take, I'm using red for this for number 1. I could cut it up like this. Those are all nice rectangles, right? I have one here, one here, and one here. That's one way you could do it. I could also, I'm going to use blue for this one. And tell me if it's getting a little crowded or not. I could also do it like this. That works, 3 shapes. Could also, brown. I could also do it like this. Right, kind of like a combo of those 2. Again, let me know if it's getting a little too crowded there. And then I can also do it like how I did for green, which is there's no other ways to like cut this up nicely. I could also just take the whole thing, and just subtract out this bit. You could also do that. That works. There's a bunch of different ways you can do it. You can pick whichever one you like the most, but just wanted to kind of show that off there. A couple other things just to go over really quick. I just wanted to go over. No. Yeah, this one here. There's 2 I wanted to go over. So this one, again, make sure you read the question carefully. It wants you to draw the net and then label the dimensions. So how many sides are on this bad boy?
Just 5.
There's 5, right? There's the front face, there's the back face, there's the bottom, there's the right side that we see, and then there's an invisible left side, right? So whenever you want to draw a net, you always start with the skeleton. So start off, oh, that's right, I can do nice straight lines now. So start off with the, I'm just going to start off with the face here, and I know that those are connected by our lovely bottom, our skeleton here, right? And then I just have, now a lot of people, again, they think you need to do this. This is not the case. These are just little rectangles folded up together into it. Have you ever seen a Toblerone box? That's what this is. So all of a sudden now I have my 5, I've drawn my net for it, and now I want to label the dimensions of each side. So now if I go to this picture here, label these sides, this side's 14 here. This side here is 14 centimeters. This side here is 3 centimeters. That's all it wanted me to do. Label the dimensions of each side, draw a net for it. We're done. So I'll give you a second there in case you hadn't gotten there. And then I just want to go to I just want to go to this one here. So for number B here, I just want to calculate. So this is on page 16. I just really quickly wanted to calculate the surface area of question B on page 16. So again, always start off here really simple. How many sides do I have? 5 sides, right? I have 5 sides, and what are they?
The front, the back, the top, the bottom, and the invisible side.
So well, if I say this is the front, there is really no back, right? It's a triangle. So what I could say maybe is like, I could say the front. You said there was the top, the bottom. There's also the side 1 and side 2, maybe. Side 1, invisible one, side 2. Just because there's not really like a back, it's a triangle, but okay. Oh gosh, that's not what I meant to do. But cool, I have my 5 sides here, right? So all I need to do is I just need to quickly come up to these. So what would be the front here? What would be the dimensions of this thing? What would I times together for that one? So what would I times together to get the front here, this thing? You know, it's the 3. That's one of them. But what's the length of this one? 8, right? That's because this one's 8. If you took a ruler, you measured it out, you'd find that, oh, this one's also 8. So it's 3 inches times, I'm just gonna make this a bit bigger so we can see. So times 8 inches equals, that'll give me 24 inches squared. I'll come back and square that in a second. So now I want to do the top, right? So the top in this case is, that's a triangle, which means it's going to be half times base times height. What's my base of that triangle?
Base.
Yeah, what's the base of that triangle up at the very top? It's tricky, right? So the base is always needs to be one of the 3 sides. We have 3 sides labeled, so I can't use the base. Instead, what I need to go is I need to use the height. So is there a height here that just goes like straight up? I see this as a right triangle, right? So if it's a right triangle, that means these two are at a nice right angle, which means that this is the height and this is the base. Or this is the base and this is the height. But either way, I know these are my 2 sides I need, right? Because there's that nice little square there. So in this case, this was going to be, I'm going to say 4 is my base, because why not? So 4 inches times, oops, 1/2 times 4 inch times 3 inch. That's going to give me 6 inches squared. Now, what's my bottom going to be? Same thing. I already figured it out. Top 6 inches, bottom 6 inches squared. What about side 1? It's this thing here.
4 inches by 8.
4 inches by 8? Yeah, that looks right. 4 inches times 8 inches is going to give me 32 inches. What's my side 2? My visible side.
3 inches by 8 inches.
So 3 inches. Oh, that's the front here, right? There's an invisible side. It won't be the same. You're right. You're right. It's going to be 5 by 8, right? There's a little. That's the length of that one. So it's 5 inches times 8 inches gives me 40 inches. Cool. I have my 5 sides. Oops. I have my 5 sides. Now all I need to do is add these bad boys up, right? So 24 plus 6 is 30. 30 plus 6 is 36. 36 plus 32 is going to give me 68 plus 40, 108. Let me just double check that. 40 plus 32 plus 6 plus 6 plus 24, 126. So total surface area equals 126 inches squared. Look at all those nice squares coming in there. So make sense? Yeah? Cool. Is there any other ones I wanted to go over? No, yeah, I'll go over some of these maybe tomorrow. Cool, cool, cool. Okay. What I want you guys to try and do then is, without your notes, you can use your calculator. This is what I like to call an exit like strip. Is that what I call it? Yeah, exit strip. Basically, it's one question. I'm giving you one question I want to answer. It gives me an idea where everyone's at. So I need to know what I need to focus on. So I'm going to be handing that out. And I want you just to give it your best shot here. I know we have not spent a lot of time on it, but I just want you to close your books, close your computer, just spend as much time as you need on it. One question.
Just the one question. I mean, but you know, it's always, never short questions now. What if this stuff?
Sorry. Oh, that's she has already. All sides. Nope. But if you have a question, I can try and help. Break them down into each side, right? Turn the hard question to an easy one. What's the surface area of each side and add them up?
Almost gonna be here 10 minutes.
Possibly. I'm not saying yes, I'm not saying no.
What do you do with these?
I take it. I've never had someone try that before. I will take that.
I just worked at it like that.
Yeah, no, go for it.
Um,
Oh, I forgot you want, I forgot to give you guys formulas. That'd be helpful. Let me, whoops. You'll always have the formulas. Oh, I'll take that in a second. So the only formulas you're gonna need for this, okay, is a rectangle, which is area equals length times width, and then a triangle, which is area equals 1/2 base height. Sorry.
think I'm trying to do years. What's that? Site 3 and 4. Let's go.